Everyone, so class 94 is actually really similar to the question that we ended last class with, and it looks specifically about Millikan's oil drop experiment. Now, the previous class didn't call it Millikan's experiment, but it was. Basically, Millikan had this oil drop between two charged parallel plates. What he was able to do was he was able to connect a battery to them, and when he connected a battery to each charged plate, let me just give me 1 second to draw here. So he connected a battery to each charged plate, or one end of the battery to each charged plate. And what that did was it created a voltage across the plates. It made one plate positive, one negative. So an electric field was created between the two plates. He then shot the oil drops with X-rays, which helped it grab electrons from the environment, making them negative. And what he was able to do is get the oil drops to kind of stay in place, like kind of stand still. So we knew that Fe, the electrostatic force, was pulling it up to the positive plate and away from the negative. We knew Fg was pulling it down toward the Earth. Since the oil drops were not moving, we knew that the electrostatic force and the gravitational force were equal. Very similar to what we just did in the last question, last class. Okay, so we were able to say that Fe is equal to Fg, therefore E times Q is equal to mg. So again, he knew the electric field strength because he knew the distance between the plates and he knew the voltage he had put across them. He knew the mass of the oil drop because he knew its size, and of course he knew little g. So he did this a bunch of times solving for Q, and he always found that his Q values were multiples of 1.6 times 10 to the negative 19 coulombs. So he figured that has to be the charge on an electron, and therefore the charge of a proton. So let's check out this question. This is similar to what he did. So one thing that's important to note here is that Millikan was unable to figure out exactly what the mass of the oil drop was by putting it on a scale, right? The oil drops were really, really tiny. It was almost like a mist. But one thing he was able to do was figure out the size of the oil drops. And, these numbers are made up, but this is roughly what he got. He found that the size of a single oil drop was 7.44 times 10 to the negative 7 meters. He found that they fell at constant velocity, so he knew Fe had to be equal to Fg. And he knew the electric field strength because, again, he knew the voltage between the two plates, and he knew the distance between them. So what is the charge on the oil drop? Don't round. One important piece of information that he knew is that the density of oil is 886 kilograms per meter cubed. So Millikan, first thing he had to do was find the mass, but he knew that density equals mass over volume, so he used that. Density equals mass over volume to find the mass. Now volume of a sphere is 4/3 times pi times the radius cubed. When you cross multiply there, you get a mass of something times 10 to the negative 15 kilograms, something very small. Then from there, m times g, so that tiny number, times g, which is 9.8, divided by the electric field strength, because you have 18,750, you have to get Q alone, you should be able to get about 8 times 10 to the negative 19 coulombs, which is about 5 electrons. Now this little squiggle here that I threw in, that little squiggle doesn't really mean anything. It just means I know there's a number there that's times 10 to the negative 15. I don't remember what it is offhand. All right, I don't have a calculator on me, so I can't work through these all again. All right, so there you have it. So just make sure, again, you're able to do all the math here. The cross multiplying works. You're able to get the density, or excuse me, the volume. Again, 4/3 times pi times the radius cubed. All right, get that first, and then cross multiply, then multiply it by, 886 to get the mass.